Area pi r square. Perimeter 2 pi r.
Shedema tutors. Cylinder volume is pi r squared h.
Okay, so this question says a cylindrical tin full of engine oil has a diameter of 20 centimeters and a height of 14 centimeters. The oil is poured into a rectangular tin 16 centimeters long and 11 centimeters wide. What is the depth of the oil in the tin? Alright, since the question says that this is poured into this is poured into this, so we told that the length of this is given and the width is given. The length is
Area of a rectangle is length times breadth, and perimeter is 2 length plus 2 breadth.
volume of a cuboid, length times breadth times height. If we do not know to what height the content that is poured here reaches, we know it might not necessarily fully. Maybe it stops here. Then in this case, the content is filled up because it's full. It says it's full of engine oil, so it's filled to the brim. This is the engine oil filled to the brim. When 16 centimeters, 60 centimeters long, and 11 centimeters wide. Volume of a cuboid, length times breadth times height. Before you know the height here, you need to know the volume. What is the volume here? You cannot get the volume because you don't have the complete parameters, because volume of a cuboid, this is a cuboid, is length times breadth times height, or length times width times height. We have the length as 16 centimeters, width as 11 centimeters. So if we want to get the height where the fluid stops, now before we get the height, we need to get the volume. But from here we can get the volume because we know that the area or volume of a cylinder is pi r squared h.
Shedema tutors. Cylinder volume is pi r squared h.
Pi r squared h. So pi is giving us 22 over 7 or 3.142 and 2 over 7 times. So if the diameter is 12, radius is equals to 12 over 2. Because remember, diameter is half. The radius is half of the diameter. So if the diameter is 12, radius is 12 over 2, that gives us 6. So since our radius is 6 now, pi r squared h will be 22 r squared, 6 squared, which is 36 times the height. Height is 14. So from here, what do you do? Cancel through. 7 into 14 is twice. 7 here, 1, 7, 14, 2. And then you're left with 22 times 36 times 2. Multiplying all through, what do you get? So, our volume here is 1,584 centimeter cube. So that, now you can find your height. What do we do to find the height? We know that volume is equal to length times breadth times what? Height. And then that gives us the length is 16, width is 11, and height is unknown. We're looking for the height, but we have volume. So this volume, this is 1,584 equals to length, height. So I divide both sides. Since I'm looking for height, what do? I divide both sides by 16 times 11. This cancels this. So you now cancel this and this. When you cancel 16 in 1,584, this gives us 99. When we cancel through, we exactly get 99. Then 11 in 99, what will it give us? 11 is 9. So our height equals to 9. And this is exactly 9 centimeter will be where the height of the liquid poured into this cuboid is going to stop. It's going to stop at a height of 9 centimeter. Very simple. So guys, this is a visual representation of what we're trying to say. Look at this. From that question, assuming this is a total cylinder, you know this is frustum because the upper circular part is larger than the lower part. It's not a complete cylinder. If it were to be a complete cylinder, assuming this is a complete cylinder and the content is engine oil, you have to pour everything from here to this place. So you're emptying it. Volume remains the same, but what changes? The height. So what we did was looking for the height at this level. You know, the height does not remain the same. If you pour back, this is what you get. It's filled up, right? But you are emptying this into this to look for. Already from the question, you are given the length and they're given the width.